Hi, everyone. In this project, we will build an LSTM deep learning model to classify customer sentiment from online shopping review. We will take raw data and predict whether each review expressed a positive or negative sentiment. So for our learning objective, we will understand natural language processing, pre-processing pipeline that include implementing tokenization, stop word removal, stemming, and lemmatization. We will go into building LSTM deep learning model for natural language processing. And then we will evaluate the sentiment model and then apply an end-to-end deep learning workflow, which basically like the production pipeline. Okay, so for our data set, we will be using Amazon underscore self underscore label dot text data set from UCI. And before we get started, let's import all the library that we needed to implement this model. That include Panda, TensorFlow, some utility from scikit-learn like transcript test, classification report, and then NLTK, which stands for Natural Language Toolkit, basically for pre-text processing like stop word removal, stemming, lemmatization, and part of speech tagging. And then we will need to import also the TensorFlow Keras model for modeling or LSTM model. Okay, so the first step in every model development, so basically we need to load our data set and explore our data set. So for this case here, I pretty much downloaded the sentiment data set directly from UCI using the URL lit library right here. And then I extract the file using zip file, and then I finally convert the text into a Panda data frame for processing and modeling the model. I'm training the model. And here's just basically I'm storing the text into a data frame variable called df. And then after I've performed a basic data exploration, we need to understand our data before we actually start to build our model. So I'm using the basic Panda library of function that's basically including shape.info to give me basic information about the data side, the info. I'm also looking at the label value, understanding what are the label for this prediction, and then just printing out a couple of rows. So let's dive into the output a little bit. So for our data shape here, it's basically 1,000 row by 2 column. And you can see here, the column are text and label. Label here is basically, there are the two label, 0 and 1. So 0 here is basically a representation of negative sentiment, and then 1 is a positive sentiment. And then here, just basically a printout of a first few row of the data set. You can see here, here's a review. So there is no way for me to plug it in, right? This is truncated, but based on this review, it's a negative sentiment, which is labeled as a 0. And then let's look at this review. Good case, excellent value. So this is basically a positive review and it's labeled as 1. So now we understand our data set. Let's go into the next step, which is basically implementing a pre-processing pipeline. That includes tokenization, load casing, stop word removal, stemming, and lemmatization of the word. So The reason why this is important is the quality of the data directly impact our model. So by cleaning it, we are reducing noise and also reducing like a vocabulary size for fitting into a model. So here, I'm creating a function called text underscore preprocessing that take in text and then verbose equals true. Basically, you could see how it's being processed, right? The display of the process. What this function does is basically take in the text. First thing it does is basically do a basically lowercase, convert it to all lowercase, and then tokenize it. So basically, it taking in the text and chop it down into individual word. And then next is basically removing all the stop word from the sentence. Stop word like is or the, right? It's part of the speech, but it's not important for fitting into a model and for the model to learn. So we are removing it here. So benefit of it is reducing like vocabulary size. And then next for forming stem of the word. So basically what that do is basically get the root form of the word. And then next is basically lemmatization of the word. So basically just getting the root word. And then I'll apply the post tagging, which is basically part of the speech tagging each word, meaning that I'm tagging the word either as pronoun, noun, adjective, all that stuff. So, and after that, here's an example. Basically, I'm reading in first row of the data set, and then just this run it through the function that we just created, and then printing out the example below here. And then I process pretty much the entire data set. So now I'm basically reading all the text, right? And then apply the, the text pre-processing function, then store the result in a new new column for each of those in the same data frame, but under different columns. So here's basically I'm storing the filter token, stemmed token, lemmatization, and part of speech token back into the data frame. And then here just basically the output of the pretext processing. As you can see how it looked like here, right? Basically tokening, splitting up the sentence into individual word, getting the base form and root form of the word, and then tagging it with nouns and pronoun. Okay, so the next step is basically building a model. But before we could build a model, we want to basically do one more, I guess, processing of our data. So also splitting our data into X train, X test, Y train, and Y test. So this part of the code does that. Let me dive into it a little bit more. So here's just basically reading in all the lemmatized token that we just executed above. And I'll basically store that into a pre-processed text, right? And then I'll feed that into the Keras tokenizer. So why do we need to do this? Why can't we just feed it into our model directly? So here, basically, I tokenize the pre-processed text using Keras tokenizer. We already tokenized the text with NLTK and the pre-processing step above. So why we do it here again is that because NLTK just give us word tokens, right? A word, which is a string. But for neural network like processing, that need to be in numbers, so it need to be in the vectors. So what this does, this function do is basically it convert the word token into a integer tensor that could be processed by the model. And then after that, I'm basically just splitting the data into X train, X test, Y train, Y test, and my input X variable is the tokenized sequence that we did above, and then my target variable is the label, which is 0 and 1. And then all I'm doing here is just making sure I'm padding the data, my X train and test train to be consistent. So I'm padding it to be with a max sequence of 100 word. Okay. And then I'm just printing out for checking, making sure the data size is consistent for both X train, X test. So I'm just basically print that out just to a sanity check. You can see here my training data shape after padding is 800 by 100, and my test data is 200 by 100. So as you can see, the shape, the 100 here, the 100 here are consistent. So, okay. So the next part is building the LSTM deep learning model. So the model consists of embedding layer, LSTM layer, dense layer, and then output dense layer. So let me explain to you what they do for each one of them. Okay, so for the embedding layer, it converts the token ID integer into a vector, a dense vector. So right now, the token text that we did in above, it's just number like 86, right? Every word is represented by a token ID. So the embedding layers basically take that token and convert that into a 128 dimensional vector or tensor. That is a number that the model could process. Think of it as giving each word a unique fingerprint that capture it meaning. And then for the LSTM layer, we implementing two layer. First layer is basically 128 LSTM. Second layer is basically 64. And then we have some dropout basically to so basically every time we run training, we basically drop out 30% of the model, basically to prevent overfitting the model. And then the dense layer here is basically what it meant is basically what it's for is basically this is where all the neurons are fully connected. So each neuron in the previous layer, the current layer connected to the previous layer, right? There is a standard neural network layer that used to combine all the learned features. So think of it as all your neurons, your brain connected all together. Okay. And then here's a dense layer output. So basically now, so after the 64, it all fit into one dense layer to predicting the output. Classification 0 and 1. 0 is negative, 1 is positive. And what I'm using here is a sigmoid function. And then I'm just compiling the model using Atom Optimizer. For loss, I'm tracking binary cross entropy. Then also for metric, I'm tracking accuracy. Then I build a model, printing out the summary. So this is how our model look like. Okay, the next step is basically training our model. So here I'm actually training through a multiple learning rate, starting out with a very small learning rate like 0.001, then increase it to 0.001, also with different epoch like a training cycle. So here is just my for loop running through the different learning rate and different epoch. And so this is just basically fitting the model. I'm feeding the X-train underscore padded data that we padded on above. Um, here, right here, that we feed in. And then and then here just my, your vi variable, your prediction variable. And then I'm basically monitoring the early stopping right here. So basically to prevent overfitting on validation loss. So if the model stops learning, then it's just gonna stop training process. And then I save the models. That way we could load into a production pipeline later on. So let's run it real quick here. Okay. All right. So it's finished. And now let's run ourselves to calculate accuracy, precision, recall, and F1 score. Um, all right. Okay. Let's interpret our result a little bit. So overall, the model achieved 77% correctness or accuracy. But it can be misleading with like imbalanced data set. So, so it's better to train with a bigger data set. And then let's dive into the classification report. So in terms of precision, the model achieved 85%. Basically, when it what this mean right here is like when it predicting um, positive sentiment, it's correctly predict 85% of the time. So that's pretty good. And then the recall score is basically 0.69. That is the model catches 69% of actual positive reviews. So every review out of that 500, it catches 69% of the time. So overall, I mean, it's pretty good, 77% accuracy. If you want to improve the performance, you could actually try a bigger data set or different tuning parameter. But okay, so how all this training and prediction feed into an actual like a production workflow or pipeline? So here is a demonstration of that, right? So if you were to put this in production software. Um, so here I'm basically reloading the model that we saved above after we train it. So I'm loading back in, I'm using that for our prediction model. In this example, so here's a customer review. The current process was good and smooth. I really appreciate it and was easy to handle, right? And then basically I feed that into our pre-text, I'll feed it into our pre-text processing pipeline that we did above, just cleaning up the text and then do a lemmatization of it, feed it to tokenizer, just to clean up the text like we did in above cell, and then feed that into our model for prediction. So, and then basically what I'm doing here is just basically I'm setting the threshold at 0.5 for binary classification. Anything less than a zero, less than 0.05 is a negative, or else is a positive, right? So let's run it. As you can see, so based on this review right here, it predict to be a positive sentiment and give a positive outcome. Let's change that. Let's change to see how the actual model actually work. Um, let's say I recently bought product from Amazon. Okay, Amazon, and it was not a great experience. Okay, let's see what the model predict. I guess all right, let me add some more negative in. So right now it's still predicting a positive. Um, let me see. All right, let's see if that will change the outcome. Okay, so now it predict it predict to be a negative review and negative experience. So so this is actually like I mentioned earlier, you really need to train a model with the data set we have right now. Um, the review, I guess it's not good to be not take the code as is to put in production, right? But this is just an example. So you really need to be bigger data set. Really need to do more hyper parameter tuning and training of the model, and a lot of training basically in order to put this in production. But as you can see, there's actual code in action, actual code working that you could actually use for production. Thank you for watching this video. Thank you.